vectors have a magnitude and a direction. They have a size and they point to a certain direction, as opposed to scalars, which only have a size. So over here I have quite a few quantities, and let's try and categorize them as vectors and scalars. I'm going to start with distance. So distance is a scalar, because when you measure distance, oh, this is 5 meters, you don't assign a direction to 5 meters, or this is 3 centimeters, right? So this is a scalar. Displacement is kind of like distance, but with a direction. In the same vein, we can talk about speed, 80 kilometers per hour, and velocity, 80 kilometers per hour in the northeast direction. Next, we have force. So those of you who do physics will know that when you draw a free body diagram, say if you label your gravitational force, normal reaction force, you have to draw an arrow with a direction. So force is a vector. Next, temperature, degrees Celsius or kelvins, that's a scalar. Volume, centimeter cube, meter cube, that is also a scalar. Time, seconds, minutes and hours, again without direction, that's a scalar. Acceleration, this is a vector. I hope that is all good. Let's quickly move on to the next one. So let's say we have 2 points A and B, right? You want to get from A to B, then a vector is kind of like instructions on how to get from A to B. First of all, AB, if you want to write that as a vector, that's your starting point A and your ending point B, both in capital letters, and then you draw an arrow on top. If you just write AB without the arrow, then you're talking about the scalar quantity, the distance from AB. Next, you can also write a small letter, right? And then write a small little curvy line below, which is a tilde, to say that that is also a vector. But in exam scripts which are typed out, they will type it out in bold. So the problem is, using handwriting, you can't handwrite in bold, and that's why we have the tilde, right? Next one, number 3, and this is quite important, vectors can be placed anywhere. Say if I duplicate this and place it on the right, then I will say that this is also vector v. So it turns out if you put vector v anywhere left, right, it is still vector v. You don't have to say this is vector v on the left, this is vector v on the right. They're all just vector v. So the learning point here is that vectors are not defined by where you place them, right? They are defined by their size and direction. As long as vector v has the same length and it is pointing in the same direction, then they are all just vector v. This is quite important. The only exception to rule number 3, when you place your vector v, right, from the start to the end, and your starting point is the origin, or you can say that if your vectors originate from the origin, then they're called positional vectors. It's a very subtle difference between positional vectors and the other types of vectors. Kind of like if you've been eating durians for very long, you will know how to tell the difference between a Mao Shan Wang from Pahang and a Mao Shan Wang from Thailand. Very subtle, but you will know the difference. Resultant vector, an example I can give you is if you go to school, you go to the MRT station, then you go to school, the result is I went from home to school. Now in vectors, we kind of have the same idea. If you go from A to B, then you go from B to C, it is the same as just going from A to C, isn't it? So algebraically, this is also very important, something that we exploit a lot in our working. And that is if you have 2 vectors and the middle letter is the same, you can cancel them out, right? And then just bring the other 2 uncancelled letters together to form your resultant vector. And now we're going to move on to a practice question where we can practice all the things that we talk about thus far in this video. I'm going to give you some time, maybe pause the video here and try it yourself. Even if you write something wrong, your answer is not correct as the solutions, you will still be learning a lot more than if you just sit down and do nothing at all. So go ahead and pause the video at this point. Welcome back. I hope you have attempted this question. General tip for vectors question is to sketch whenever possible. In fact, I would say it's a tip for all of mathematics. If you can get away with a sketch, exploit it. Use it as much as you can. Regular hexagon means that all sides of the 6-sided shape have the same length. So AB can be represented by the vector P. CD can be represented by the vector Q. Let's first focus on BE. So I'm going to draw a line from B to E. The nice things about a regular hexagon is I can divide my regular hexagon into 6 equilateral triangles. So I'll leave it to you to prove or to satisfy yourself on why this is an equilateral triangle. Now, if these are equilateral triangles, then I will want to call the center maybe O. Next, you might realize that if these are equilateral triangles, then this and all the other lines here are the same length. And you find that BO specifically has the same length as CD, and it also has the same direction. Since they have the same length and same direction, I can call BO vector Q as well. Remember that vectors are not defined by where they are placed. Right? As long as they have the same size and same direction, we can call them the same vector. So in the same vein, I can say that OE is also Q. So that brings me to the solution for BE. That's kind of like BO plus OE, but I can cancel the middle letters. So BO is actually Q, and OE is also Q. So BE is just 2Q. Great. Let's now do BC. So BC is over here. BC will have the same magnitude as P and Q, but obviously it's in a different direction. How can I find BC? And this is where we can exploit resultant vectors. BC can be a resultant of two movements, B to some point plus that same point to C. And what is a convenient point to choose? Well, you can choose anywhere you want, but I think we want to make use of results that we already know. I could choose BO to OC. So let's write that down, BO plus OC. So BO I know is Q. What is OC? So remember that OC, again, is the same length and direction as AB. BO is actually Q plus OC, that's P. So that's Q plus P, and that's the answer for BC. Now let's find the last one, AE. And I'm going to employ the same strategy as we use. AE is the resultant vector of two movements, right? Two vectors. A to some point plus that same point to E. I can do AB to BE, right? I think this one will be a bit more convenient. So that's AB plus BE. AB is just P and BE is just 2Q, taken from here. And that's it. So I hope to see you in the next video. And until then, catch you on the flip-flop.